Steve is volunteered to do the 20 meter this week. He's going to try to do it live. And so feel free to ask questions. And if you want to put it in chat, I'll be monitoring chat, and I'll forward the questions to Steve when we get an appropriate break times there. And so after the fact, we're recording this thing. We're gonna edit a little bit and then put it on YouTube. So if you guys haven't seen our YouTube channel, just look up Society of Amateur Radio Astronomers and subscribe to our YouTube channel. Not that we're going to make any money out of it, but it's just another way to get the amateur radio astronomy to the masses. Okay, and Steve's been doing this since I've known him, almost 4 years now, and with the 20 meter, and so he's pretty good at it, and so and he spent a lot of time at it. So you've got pretty much our expert on the 20 meter right here. So feel free to ask some questions while he's talking. And okay, Steve, go ahead.
Okay, thanks, Rich. I'm going to spend this live interaction on the Skynet website, so that'll avoid any sharing and unsharing. So there'll be no PowerPoint here. It'll just be me talking, interacting with you. I'll be making some key points as we go through this. Those of you who've been to Green Bank, when I do the Skynet demo, it's usually in two parts. One is a PowerPoint presentation, and that's essentially my own learning experiences through the year, and I put them in a PowerPoint, part of an ongoing sort of unofficial instruction manual of what you could do and apply the Skynet towards. And then the other part, and that's about an hour, and then the other part, an hour until people stop having any new questions, is an informal session, just like we're doing here. It's just whatever comes to mind to ask. So I'm hoping that the Skynet network is up and running. It was a week ago, although it was a little bit spotty. But hopefully, most of the time, Skynet is you put the observation in and it's immediately working. So if you had Green Bank, you can see the telescope slewing to its target. So that's what I'm going to start here. It's very easy to operate, and you'll see that. The hard part is interpreting what you've seen, what your results mean. I think all new users, including myself, when I started on this, I think their key goal is just input data and see what the signal looks like and not really interpret anything, see what you get. So that's what I did. But then I would ask myself, what can I do with this? Because it is a professional telescope. It's a 20-meter telescope. What can I do with it? So over the years, I've looked into different aspects of that, and I posted those PowerPoints. If you go to the SARA website, under the sections, analytical section, you can see the PowerPoints posted. There's one that talks about the Cassiopeia A observing program. That was my first application of the 20 meter. I was trying to learn how to obtain a flux value from observations. Easier said than done, but I attempted it. And that was based on a paper by Dr. Reichart. He had a lot of graduate students for his paper, so his was a professional job. I was trying to take some shortcuts. So if you're interested in flux values, you can look at that PowerPoint. Another year, I looked at the Pulsar observations with the 20 meter, because that output screen is pretty sophisticated. So I want to learn what all the screens meant, and you'll see that PowerPoint. Last year, I was looking at astronomical masers because there is a filter in here hydroxyl molecule that can be used to look at astronomical masers. So I put a demo together on the basics of that and the quantum chemistry behind that. This year in July 30, 31st, I think the dates are, I'll be doing a presentation on the raster scans, or the mapping with radio images, and maybe a little bit there on attempting to calculate some temperatures. That's already posted, though I haven't presented it. So you have some materials there. The 20-meter website has also some materials posted by NRAO. So you can look at those. Those are probably your first stop, the basic observations. So what I'm going to do now then is after I've typed in the password, and you can sign up for the 20-meter. You have to be, though, a US citizen for that, because that's part of the requirement for the NSF grant. But you can contact me if you are a US citizen, and you can get time on the 20-meter. I'll give you the password. So I'm already in there now, and the first page you're going to see is a screen that looks like this. And you're going to go to my observatory. The Skynet network is both optical and radio, but for SARA, we have the radio, and you can click on to radio. Now, can everybody see welcome to Skynet?
Yes.
Okay, let me start with this screen, and maybe we'll try to log in later.
I would say go ahead and turn your video on, since that wasn't the problem after all. There you go.
All right. Well, I'm not logged into Skynet. I'm logged into the Skynet public site. So anybody could go here and look at the observations. And I had mentioned earlier that on the SARA sections page, I posted some PowerPoints on my demos over the last few years. The other things I wanted to bring people's attention to are the websites like this. You can log on to see all the results, and you can log on to, well, you don't have to log on, just go to the website. There's no special requirement. This particular site you can come to by just Googling Skynet. I'm sorry, you can mapping advice NRAO 20 meters. I saw a link and I went into there. But some of the other similar ones are observing advice for NRAO Skynet 20-meter telescope, Skynet log of 20-meter data, and we can get to them through these websites. So this particular one has different pages. Let me see if I can go to a more suitable one. Main observing advice. And everybody can see that, right? Had we gone into the Skynet site, you would come to a screen that would look like this, a globe, and you would input your target into here. You can pick from the globe, or if you had something else in mind, you can key that in, and then it would bring up the observation, give you the coordinates. You could set some parameters if you want, minimum elevation. There's reasons not to keep it so low to the horizon, a minimum separation from the sun. There's reasons for that too. In this screen, they have the Crab Pulsar or nebula. It would bring it up here. If you're a SARA user, you'll get some advice from me that after your observation to put your initials. That way we know who in SARA entered that. You'll have a screen here that says when your object is in the horizon. Obviously, if to go instantaneously, it has to be in the sky above. If it's not, it'll have to wait, but usually it's instantaneous. Then you'll come to some screens that look like this. It'll ask you for what mode to put it in. So you can have a low resolution mode, which is also the mode you'll want if you want to check mark the pulsar mode, if you're observing a pulsar. You'll have a couple of filters. The main filters for this receiver, we're in L band, would be H1, so you can observe hydrogen 1 in the Milky Way and beyond, or there's a couple other ones in here. They're not on this screen, but you can drop down and you've got two sets of the OH or hydroxyl molecule. There's two ranges of them because there's 4 frequencies that you can catch astronomical masers on, or you can just do a wide range for the frequency. So you put that in. You can also do high resolution, in which you're actually picking your center and secondary frequency. So again, you can choose the actual frequency within the L band limits. You may ask, is there anything else besides L band? Well, there's only one receiver at a time on the 20 meter. It's usually L band. Sometimes they put an X band on, and you might wonder, well, what good is X band when it is on, because you don't have H1. The X band range is, I think about 8 to 12 gigahertz. So you're not going to get hydrogen 1 with that receiver. You're not going to get the hydroxyl. What is that good for? Well, you've got a much better resolution with X band. L band, you have a beam that's about 44 arc minutes, which is not too different than the sun or moon apparent diameter. So you're not seeing a lot of detail on that. So if you've got a pinpoint radio galaxy, it's going to be spread out, at least the radio image, if you do a raster scan over the beam area. You won't get any kind of structure within that 44 arc minute. And if they have the X band set up, that beam size is 7 arc minutes, and that's where you're getting something smaller than the apparent disk of the sun or moon. And in my upcoming summer demo, and I've got those slides posted, I found one observation going through the log of the sun that was an X band, and it looked like there was an actual solar flare coming off the disk. You could get to that detail. So I checked up on that date, and there was indeed some solar flare activity. So it's my opinion somebody put in the observation knowing there was a solar flare there and actually captured it in a raster scan. So that was an aha moment that, that's what X band is good for. It's much better resolution. Once you put that in, the next screen you'll come to is the path. And if we can get back onto Skynet Live, you've got 4 paths. 2 of them are similar to each other. In this one, they've selected in the example a track. You're basically, the antenna is following the object as it moves through the sky, or basically as the Earth is rotating, it's tracking that object. There's something on-off tracking, where it's moving from the object off maybe by a couple degrees and back on, trying to account for the background. I've found that of limited use through the years, because if you're observing something around the galactic equator, it doesn't matter if you're going on, off. I mean, everything there is, you've got a lot of concentrations of H1, so it doesn't do too much good. Here it is, on, off here. Then you have something DAISY and MAP, which are very similar. A map is, as the name suggests, an actual radio map. So you have the 20 meters, slewing back and forth and making a rectangular pattern of the image. So the closest that you can maybe have to an optical image. The daisy is, it's doing a loop pattern. The difference is because you're not scanning an entire section of the sky, it's saving a little bit on the cost. Raster scans, if you go into the default of the raster scans, which are, they recommend 6 beam widths, but here they've got 8. Usually the default is 1/10 of a beam width. So that's kind of really close together. That would be 18 minutes of radio telescope time, and that eats up the budget fairly quickly. Not that you couldn't do that, but warn us ahead of time. Let us know what you're doing. But when I was doing the raster scans over the last few months, I found a way to get them down to just a few minutes. And what you can do there, instead of having the telescopes skew back and forth in 1/10 of a beam width, you can select something smaller. I believe here it is 1/4. That reduces the time a lot, and then of course keep it to about 6. So there are ways to keep the cost down on that. You see the difference in the pattern when you have 1/4 beam, so the spacing is great. You can actually see the slewing of the beam as it's creating the image. Whereas when it's tighter together, it's not apparent at all. And then you have like an integration time. If you're selecting Pulsar mode, there are some specific instructions to that. I was just browsing it the last few weeks as far as maybe a topic for 2023. So in the past, I've done understanding the Pulsar results page, but can you really collect any data that's meaningful? And there's a lot of data on the observation page of the Pulsar's observations that when you look at them, they're not very good observations for one reason or the other. So I did go back and refer to some of the instructions. They're saying, well, you need an integration time. I think it was about 1/1000th of the pulsar period. So I believe the crab pulsar is about 1 second or so. So I put in 1/1000th. I think that's the minimum you can put for integration time. But it's when you're trying to apply it to some observations, you've got to see what you have, and then could you have done a little better and kind of research what went wrong. So those are the pages, and then it's a matter of submitting it, and it'll go through, and you'll get to see the observations. Now, hopefully, I'm going to click this, and well, let me take you through the other things here before we sign back on. There is a log of 20-meter observations, and you should be seeing the page that has all the observations in it. That's not just only the SARA members, that's everybody who's using the radio telescope. And there's quite a lot. This whole page was just 2022. You can go back until the beginning of 2013. They do include some new features every year. In 2021, I've noticed, I'm sorry, 2022, I noticed there's a button where you can press and see the summary of your input data, which I thought was useful. It saves you the extra step of trying to look at the raw data and figure that out. So that was pretty good. But you can look at, so if you're not a US citizen and can't log on, you can look at the observations, you can get the raw data. You can't get the raw data though for pulsars because that's just too much. It would require too much space, but there is a link on, I believe it's the analytical section or maybe the stellar section, where Skip Creeley, who's one of our SARA volunteers, he has the ability to try to go back and get that data. It's a little bit time consuming, but it is possible. So let's take a look at, I'll just pull one up. I'm assuming this is a Pulsar PSR. And obviously it's not in Pulsar mode. I don't think this is a very good observation. It's not telling you much, but let's take a look. You can see all the raw data in here. So if you had your own algorithms or software, you can map this yourself or use what's on Skynet. So there's a lot of data in here that's if it's non-pulsar related. So the name of this observation was Pulsar, but they didn't put it in Pulsar mode. Let me actually give you a, because I tested one on, I tested the tracking. No, there's a lot of.
It seems to be back up now.
It is? Okay. So what I'm going to do then, I'm going to go right back up there to, let me go back to this page, UNC Skynet, and see if, oh, I'm logged in apparently. That's good. Did it actually remember? Oh, it did. Can everybody see that I'm in the Skynet observatory now? Okay, that's good. So I believe I was one page before where I went to my observatory. I clicked the radio observing where we have a SARA count. In fact, if you want to look at the count for SARA, you can see that we've got 12,945 seconds in there. But we'll go to the radio observing. So I did a test last week. You can see my initials there. Just wanted to make sure it was up. I canceled a few because I was waiting and they weren't coming up. So I just canceled them. But this one went through. So that's what I meant. It was a little bit iffy the past couple of weeks, but I went in here. This is just a simple track. They have some observation guidelines, and I would recommend those Google searches where you find the instructions, mapping advice, and so forth, and follow them for the type of observations you want. I don't have them memorized in my mind, but you will get, here it is. This was the observation information. So I selected, I knew it was in the sky when it was, I had the map. L-band, I did high resolution. I centered on the hydrogen. This is the tracking on H1. I did a duration of 1 second. That's not really enough for a good observation, but you would get results for 1 second. So that's all I was doing. You would click this when it's done, and you'd get something that looks more like oh, I have to be mindful. When I'm on this screen, you're just seeing the observation. You're not seeing my zoom boxes, are you? Like no. I'm moving a zoom box right across the screen now. Are you seeing that?
No.
Okay, that's good. That's not distracting you then. So for this one, I had the H1 observation. You can clearly see that. My interpretation of this is you're not seeing the hydrogen line from the Crab Pulsar. What you're seeing is probably the hydrogen in the galaxy in the direction of the Pulsar, Crab Pulsar. And sometimes you can see this in observation. You have double peaks, sometimes triple peaks. My opinion is you're catching the different layers of the galactic arms, and they're shifted by Doppler, and that's why you're seeing that. But this is a straightforward image. If you were to do that, you've got two polarizations. Going by memory, I believe that's the two polarizations, blue and green, and then you have two frequencies. So these are the two frequencies I chose. So obviously the one that's centered on the 14 20 is the H1. I pressed a couple of these in the logs, but sure you can see that there's detailed information on the data and the information here that you can look into, and raw data, calibrated data. The file descriptions, that just gives you some basic information on what all of this means. So that might be useful. If whether you're on the public site or in the 20-meter site, I was encouraged clicking as many of these as you find. You will find different documents, including the ones that they use to calibrate the 20-meter. They all have some information, useful information in them. Now, when I did the data file, it brought up a new tab. Were you able to see the data file screen? Right now, it says explanation of 20-meter telescope data files. Are you seeing that?
Yes.
Okay, good. And now when I'm lowering that, you should go back onto the observation page, correct?
Yes.
Okay, good. If you click the bumblebee, you'll get a different view. And you can explore these. The 20-meter info is basic. They're basic guides. If you did the log, you'll get the log. If you did the latest, you'll get the last one on the list. This is the new button I was talking about for 2022. If you click that, it gives you that information on the observation, which is very useful. You don't have to go searching for it. And you can see this is our account. So what I think I'm going to do now to actually demo it. So let's submit something then. The way you submit something is add a new observation. There's that, I can either key in a topic if somebody wants to see something, or you can select something from here, and we'll go through the options then. Does somebody want to throw out something for me if you have something of interest? And by the way, you can always go back. I can leave this in here if it's not actually immediately activating. You can come back and find that observation on the public log. But hopefully it'll work.
Some Milky Way H1 example.
Well, I'll need coordinates for that. And if you have something that is not necessarily a target, you can put your own coordinates in here to view the area of the sky you want. Something I did was interesting, which is in my raster scan. In fact, H1 is almost everywhere where you point the 20-meter. And I was reading one day, I was curious, is there any place you can point the scope where there isn't any H1? And there is something called the Lockman hole, which is very little H1. And you see the tiniest bump of an H1 on the chart. I thought that was interesting. That's in my raster scan presentation. But so that's one thing. You can put your own coordinates in if you have something. I had to do it for the Lockman hole because there's no target called the Lockman hole. I had to select that region of space. But if you do have a target that's more specific, I can put that in there. I mean, someplace obviously in the Milky Way would be along the ecliptic. I'm sorry, the galactic plane.
Steve, can I make a suggestion for an observation?
Sure.
Because that's probably something that people don't have seen, which is should be doable with a 20-meter dish. If you go onto Cassiopeia A, and I'm not sure, but it should be above your horizon, and then take a spectrum of hydrogen. The interesting point is if you look at Cassiopeia A, And take a
Okay.
hydrogen spectrum, you are seeing an absorption spectrum because you have the bright Cassiopeia A and the hydrogen between Cassiopeia and yourself. And
Let's
you see
pick that then.
and absorption lines. So if you want, let's give it a try.
Okay, let's do, I picked that. Well, it should work. Maybe I didn't get exactly on the X, but what I could do then is just put the type in the name, Cassiopeia A. Did I spell that right? No, I didn't. One extra S. Search. It found it, supernova remnant. That's good. Then, oh, one other thing. You'll see this here. You can, it's set to RA declination grid. That's the default. If you're near the horizon and you did the azimuth elevation grid, you will get different results on the raster scan. And I've kind of note that in my raster scan demo PowerPoint, but keep that in mind. That's something if you're applying this. So we have the coordinates. I'm going to leave it at 20. We're just right here. You can see the solid line is set at 20 and we're just above it. So we should be able to capture it. So I'm going to say save and I'm going to put, you'll find it because I'm going to put my initials after it. And then save and continue. We're in L-band, and so you have a choice now, low resolution, as you see here, or high resolution. And
you would go to high res.
Okay, and you can pick your frequencies. It's centered on these, and if you wanted to do H1, I would recommend leave them as that. You can pick more channels. I'm not sure if it does anything meaningful, but we can, if you want, it goes up to 16,384. It doesn't.
Well, that would be actually too much. If you leave it at maybe you can go to 2,000, and that's fine.
All right, we'll do that. I don't think it makes too much difference in time. So I'm going to save this. And we have a choice. I would recommend that we track this first because tracking is rather than on and off. I would recommend that we track first. I would leave the integration time as is. I can put in whatever duration that you'd like to see here. You will get results that, excuse me?
Just a couple of seconds for the total.
Okay, yeah, you will get something,
right?
right? A couple of seconds and a save and continue. So here's the information that it summarizes. 2 credits means 2 seconds, and we're going to submit this. And you can see that it's been assigned an ID and that it's ready. I'm going to give it a few seconds to start slewing. If it's indeed active, we'll know.
Is there a live camera?
Excuse me?
Is there a live camera to the dish?
I'm not sure. There are live cameras for the optical scopes I've seen for the accounts that have optical. But there is a page where you can go to as you're exploring the Skynet site, where it says, it lists all the telescope, optical, and the one radio at the moment. They're planning to get more in the future, where you can see a photo of the location. But I don't know if they have it for the 20 meter, but you can explore that and see. So take a look later at the optical locations. Now, as I'm learning to do these a little better and better each time, I refer to some papers by Dr. Reichart. He is an astronomy professor from the University of North Carolina. He oversees the Skynet program. And he's written some papers with his students, his PhD students, on really getting very good science out of the 20 meter. He uses a lot of other tools that go beyond this site. And I'm going to read them to you, but you can Google them. So the way I'm reading them, if you Google that, you'll find his papers on the internet, and you'll see the high level of sophistication that goes into his reports and what you can really do with this telescope. So there's three. Two of them are similar. His first one that came out was called, you can Google this, Fading of Cassiopeia A, Reichart 2017. You should get the link to that paper. A very good paper that talked about how to take the flux values, and it was a very big statistical document to make those flux values accurate, but very interesting read. And then is a more recent one, 2018, you can Google Dan Reichart, Processing Algorithms for Single Dish Radio Telescope, and then followed up, I think, a little more detail in 2019, and that was called Skynet Algorithm for Single Dish Radio Mapping, Contaminant Cleaning, Mapping, and Photometering Small Scale Structures. So that's quite amazing what can be done, and I would recommend you look at that. So let's take a look at where we are. I'm going to see if it's completed, ready, or in process. I'm just going to go to the second page. And did I freeze up again? I was just going to go second page back to the first page so that it, your observation, oh, that was the request I had in there originally. Now, am I the only one that's freezing up on the Skynet, or are some others experiencing the same problem now? It looks like it's back down again. But what we can do is we can see if that observation was created at the public site. So let me see if I can go in and catch that again. I'm going to type in what I typed before. Let's see, Skynet log of 20 meter data. Log of 20 meter results. I'm going to go to the end. And yes, it's ready. So it did go through. Let me pull that up. And I think from what I recalled from memory, that Cassiopeia A does show that Doppler effect. At this point, I'm going to ask you, can you see the observation we did just now of Cassiopeia A's, or it's stuck on the Skynet site?
We got it.
Yes, we can see it. It's actually what we would expect. What you see are absorption lines.
Yes.
So it is the bright Cassiopeia A, and the hydrogen between Cassiopeia A and our cells absorbs. This is why the lines are going down.
And I've seen this in other observation. Sometimes you get three peaks or absorption. Yes. So
the main point here is that, in contrast to when you look at other sites with a larger dish like the 25 meter dish, you can see absorption. Maybe if that doesn't distract too much, I can show you a slide which explains that. Is that okay with you?
Yes, I would have to stop sharing for a moment. So let me see how I can do that. Well,
should be at the top.
Oh, there it is. Stop share. Okay.
Okay, I'll start sharing. Can you see my screen now?
Yes.
Okay. So this is a solar system. We are looking in this direction. This is where Cassiopeia A is. And that's a broadband emitter. So it's emitting all over the frequencies. And the hydrogen from these two arms absorb. So it's the radio waves have to penetrate hydrogen and it takes out that energy. And this is what we are seeing as absorption lines. You know, if you go back, if we in a minute go back to Stephen's slide, this is exactly what you're seeing. These three absorption lines, they're a bit more better resolved here in this slide. So this was what I was hoping to see. You can't do this with small telescopes like a 3-meter dish because you have too much hydrogen emission over a broad range, and Cassiopeia then would be too weak. But for a 25-meter dish, this is something that can be done easily. So
I have a question for you. Is there any particular directions when you're pointing, you'll know that you'll have an absorption line versus an emission line? Is there any way to know that?
Yeah,
I mean, other than going...
what you need is a strong emitter in the background. So Cassiopeia A is probably the best choice. You also can see that in Cygnus A, you should be also be seeing an absorption line. I believe also if you look at the Crab Nebula, which has about a 900 Jansky emission, there's also an absorption line. So if you, whenever you look at a strong broadband source, you can see absorption lines rather than emission lines.
Okay, that's good. Okay, so I think you're seeing the Cassiopeia A results. There are, and you have the raw data files here and calibrated information. We can take a look at, usually the, it's in power in kelvins or sometimes in counts. You can see the two polarizations and the two frequencies. We can switch to this view and it's providing this display. I'm going to go back now to see if we can get back onto the site. And you should be seeing Skynet site, is that correct? Okay, good. So this time what I'd like to do is get another target and see if we can
What about 3C273?
Okay, let's do that. Is that in view? 3C273? Well, we'll find out. So I'm going to search. So we have a, I believe it stands for a blazer. We are not, it's not above 20 degrees. So let's go back and pick something that is. Let's do another, because you would have to wait for that until it was. Shall we try something that's higher up, maybe 3C147? Or you can suggest, it doesn't matter.
I'm going to put a request in the system of RA6 and DEC 20, because that's some data I've been processing.
Okay, let's, RA is what?
6 hours.
6 hours?
Declination plus 20.
Oh, declination plus 20. Okay. What should we call it?
AP.
Okay. Let's, so it's right above the horizon now. We could do tracker. I'd like to do a raster scan if we can. Okay, so we have both our initials there. Let's try that and see what we get. I'm going to do a fairly non-detailed raster scan just to show that what it is. All right. have any preference for high resolution or low resolution? You can get scanning on both. Okay.
I'll let you pick it.
If we were to low resolution, notice it's on H1. We have the 2-hydroxyl here, and we have all. When you do all, you're running the chance that you're going to get satellite interference.
Just do H1.
H1, okay. Let's try a little bit high resolution. We'll keep it at that same number of channels. We'll save and continue. We're going to select map. And so that we don't have to wait 18 minutes, I'm going to have the beam lengths not 1/10, which is default, and you'll see that it's requesting 18 minutes. If we lower them to the lowest possible, or the widest separation, 1/4 to 1/4, you notice that drops down to 2.9 minutes, so very doable. The big difference you're going to see is you're going to see the slew pattern of the beam. So we'll keep everything here. 2.9 minutes is 173 seconds. So we have that. And let's see what we get. We'll submit that. Your observation request was successfully submitted. What I was trying to do before was if you just wait here, it's not going to refresh itself. So what I usually do to refresh itself is change the page and go back to the page, and you'll see that it's active. So these were things completed before. I'm going to go back to page 1, and you can see that it's active. It's working. So that's a good sign. We have to wait about 3 minutes. So while I'm doing that, I'd like to bring up the point that, because this is, if you're new, it's going to confuse your interpretation. Those of you who have access to very large or even amateur optical telescopes, your field of view looking through them is quite small, arc seconds, arc minutes. And because the field of view is so small, you're going to slew to the object, even with a professional scope. And sometimes the target you select in the library catalog of objects is not exactly dead center. So you might have the tendency that when you're making a radio map that you might find the image off center, but not so. It is centered, and you have to keep in mind when you have such a large beam size that your field of view is no longer arc seconds or arc minutes. You've got a number of degrees on both axes, and it's quite a large field of view, and that your beam width is showing nothing resolved within that 44 arc minutes. So if you do see something off center, say for example, because I was experimenting with this until I knew better, I would put in maybe say a planet to see if I can get any signal. But let's say I just put in Saturn, and there's many others. I've checked this before, people who've put in, even some of the scientists, different planets. They would be weak emitters except for maybe Jupiter. But you'd get an object sometimes. It'd be a little off center, but if you did a little more research, it's not the planet that you picked up. It just happens to be a satellite right in that same ecliptic. And actually, the sky is crowded with satellites, and you'll be picking them up. And you have to wisely interpret what you're seeing. Is it interference, a satellite? What is it that you're seeing there? So, and then sometimes when you're onto an object, just the algorithm of how it puts together the image in this large field of view just happens to look like somewhat like the optical image in a very narrow field. It's just coincidence. So we had some discussion, it was on the listserv. SIG somebody had I think it was a great experiment. Somebody had a raster scan of SIG-A, and it just happened to come out to look like the optical image, but the field of view axes were completely different. You wouldn't have resolved SIG-A, but that's just the algorithm of the radio image, how it portrayed it to look somewhat the same. So you have to be a little critical when you're looking at these images, and are you really seeing what you have thought you did, or is it something else? Let's see now. And in my the raster scan PowerPoint on the SARA analytical page, I've got a couple slides in there about understanding beam widths, what it means, how it's defined. You get a better appreciation how to think in radio frequencies and not how you think maybe in optical viewing and optical images. So let me see if this is done. I'm just going to refresh the screen. It's still active. Okay, so we have to give it a little more time.
How many people are online accessing the antenna?
I've had 15 people request through the SARA account. So what happens, they'll send me an email. My email is, best way to get that is go to the SARA section's analytical page. I'm the section coordinator, so you'll see my email address. Or just go to my PowerPoint presentations. In fact, at the end of the PowerPoint presentations, I have 2 email addresses. So in case you don't get me on one, you'll get me on the other. But make a request. You're interested in getting an account, and there were 3 requirements for the NSF. One of them you'll just be stating in an email. I'll give you the language, but it'll basically say I'm a U.S. citizen, and then you'll state your purpose as to why you want time. And it could be a sentence or so. Most people say for learning experiences or instruction, and then you'll agree not to point it at any non-man-made objects, which essentially means don't track satellites with it or other spacecraft. And then I'll send you a the account information and password, and you can go on, and we'll just put your initials after that. We really didn't know what to expect when we first got the accounts, whether funding would be depleted quickly, but no, it's people have been responsible. I believe we buy it in chunks of 5 hours of time or 3 hours. It's not too costly. You can get individual counts. You can, there is a website, Skynet University, where you can take for free, but there is a $60 processing fee, the Skynet Observation class, where you get, well, definitely optical time. I'm not sure if you get radio time. You can check with Dr. Reichart, the instructor. But they'll give you a free account with some funding in there to experiment with. Sometimes local astronomy clubs buy an account just like SARA did, and you have time that way. But there's a lot of different ways to get onto Skynet. And in the future, this was an announcement I found on Dr. Reichart's page, where they're expanding the radio telescope network. So that, I believe, will include PARI and a few other places. Let's see if this has been completed. It's completed now. So let's take a look at what we have. Hopefully we'll have something, and it didn't have any corruption of data. Now, here it is. So this is a fairly large screen. So you're getting the tracking result, large H1 peak. And now you're getting the images. You can see to the slew path, because I selected 1/4 beam, they're quite spaced apart. And that's how we got it down to 2.9 minutes. If it was 1/10, this would be much more tight. And you can actually see it slewing back and forth, the center of the beam that's most sensitive. You can see it in, as you see here, the beam is kind of moving in that direction back and forth. It becomes more apparent. Now, the center, the coordinates you gave me are dead center. You can see that it's not arc minutes or arc seconds. You actually have 18, 19, 20, 21, 22, 23. Is that 6 degrees? Yeah. And how many degrees here? 88, 89, 90, 91, 92, 90. 6 by 6 degrees. So it's a large section of the sky. So even though your center is here, you picked up a target here. What that is, you'll just have to get these coordinates and see if that is maybe a radio galaxy, if anything on the celestial sphere corresponds to that. It could be a satellite. They do look like that, especially if you use the whole L band. We can go look at the raw data.
Didn't we submit RA6? 6 degrees?
We did
Or
6.
6 hours, excuse me, 6 hours.
No, well, it's
and that's degrees.
If you convert the degrees to hours, it'll probably show up as hours. I think it should. I think the RA is well, that's a good question. I didn't look at the coordinates of input there, if 6 defaulted to degrees or hours.
No, I think it's correct. It's 6 hours is 90 degrees. That's fine.
Okay. I would have looked at another observation that to see if it was hours or degrees. I just assumed it was hours. So when I'm looking for something like this, I have to do the conversion of the RA to get hours. So this is giving you, as before, you've got your 2 polarizations and you've got your 2 frequencies. Now, what I've noticed on some of these, which can be tricky sometimes, is notice that at least for these polarizations at this frequency, the power scale is somewhat similar. That's why you're seeing the mapped object. But for some strange reason, sometimes I've noticed that you might have one polarization in one type of power scale, and then it switches and changes everything so that the 36 up here, which is corresponding to this, it might shift that 36 down into the blue and have something higher up here. And then you'll see that there's a completely different image and you're saying, well, what happened to that object? It's still there, it's just shifted on the power scale. I've noticed those power shifts when you're getting close to the horizon, it tends to change things a bit. But keep that in mind, not only the degrees, but the power between the different scales. Here they're very similar, but they can be off quite differently. And then at the other frequency, you have it again. So it's, oh, and I might bring up too, this is another important thing. You'll notice a little circle in each of these images. That's the beam size, beam width. So you're not going to get any resolution within there. Sometimes when you bring up the sun and the moon, you'll notice a patterning of layers, just like you might see it a little darker here. This is not structure in here. What I think happens is, as it's going back and forth, you've got the center of the beam that's going right through this, so it's much more sensitive. And then as it's coming back, you're not getting the center of the beam anymore. It's maybe somewhat a little bit out from its center, and it's still sensitive, but it's picking it up a little bit differently. So that's how it looks like you might be getting something within a beam size, but really it's just how the center of the beam is hitting it, at least as I see it.
Quick
So
question on the Fitz files. So we can download the Fitz files.
Yes,
And
we
is
can.
there a good Fitz viewer? And I think the Fitz viewer allow you to change power levels or whatever within the Fitz file or the Fitz viewer.
Well, let's take a look at the raw data or the calibrated. Let's go into this. So clearly we picked up something. It's not the coordinates you gave because that's dead center. It's something near there. Let's see if we can figure out what that is, because you're going to see the frequency come up higher there. So let's, I'm not sure what the best one to pick here, but let's start off with one. That's just a summary. So let's go to this. And now you're seeing the I believe two different polarizations for the frequency. Here it is, frequency 2, and the two polarizations. So it's starting off, it starts off at a calibration baseline, but as you go through, you're going to see a, let's see, you're going to see these numbers increase to a peak. Well, because it's centered on those two things, I'm gonna probably say you picked up maybe a hot spot of hydrogen without doing any further research. If this was a wider band of over that whole L band, you might see that some of these are peaking at another, well, they'll probably have a center frequency of like 1500 if we did the wide L band, and then 1500, and that's the thing that's peaking on the raster scan, and that's usually satellite interference. Let's see. So you can see it's increasing. Well, let's see. Is it increasing? It didn't increase too much. Let me see if we can get another view of this. Let's see if this makes a difference. Oh, in this view, you're getting the actual coordinates too, so that might be helpful. Again, two polarizations, your two frequencies. This is giving you some information about the calibration and baseline. So this actually looks a little better. So let's see. And I think what you're getting here are, I think C stands for counts. So let's see how these counts go as it slews back and forth. Let's see if we can get a peak count. Looks like it's a little higher over here. And I forgot what my axes were here. So we want to look at these three. Let's see if we can try to correspond that to the map. So we have RA, which is the second column, and a declination. So both of those in degrees. So that should be able to help us match that up. So it looked like when I was scanning them that this was a kind of a peak here. So this is 92 or 93 and 22. Let's see if we can match that up. 92 and So there's something at 92 and 20 and a half. Let's do that again. Oh, I think I have to. No, no, that wasn't what I picked before. Okay. It was declination that was 22? I mean 20 and a half?
Yeah.
I should have wrote these down.
Yes.
Okay,
The
so
declination was 20.
20 and a half. Well, let's see if and 92. Well, I don't want to take up too much time here, but you would have some information here, and then you would try to correspond it to the map. But that's how you would match it up, I believe. Sometimes, you know,
Spectral information?
well, I think I pressed this.
There was one that said spectrum ASCII.
This one here?
Yeah,
That's ASCII. If we go back
Okay.
to the other view, it said spectra calibrated. All right, let's, but that's not giving you the coordinates. It's just giving you the frequency.
Is there an image? Any spectral image of a frequency response? Of a frequency range? That's just calibration. If you scroll down, is there anything?
Oh, you're saying.
Spectrum? That's just total amplitude.
So it was showing, oh, hold on. Oh, live spectrum. Maybe that came from the data there. Maybe that's the same bond. Let's press this and see what happens. Okay, there's a lot you can explore on this. It's depending what you're looking for. There's the text file, and I believe spectral calibration text. Let's see if spectra calibration text, there it is. I think that was the same name. So that chart then looks like it's based on this data. Oh, so maybe it's not giving you the coordinates though. I would suggest, because you could spend a few hours looking at this and checking what is what, to go in here and grab those data files and see if you can match them up. Overall, I think it's a good chart of whatever you were trying to find.
So I can access this, right? I can access this data.
Yes, even without being a member, just go to that Skynet log of 20-meter results. And you can, here's the name of it. So when you get into that log, it's going to basically be log of 20-meter near the bottom, because you're not going to have many people today that are submitting results. You're going to look for this name. That'll allow you to go in and press all these links and try to match them up. And how helpful the information is basically what your input, what you've used for the input parameters. I've seen some of the data that's easier to use than others. But you can, so that's where you can try inputting different filters, see what you get, and see if you can make some sense out of that. And so, for example, 20 meter Skynet data. I'm sorry, that's, oh, log is what I wanted. That public page will take you. I have my, here it is right down here. I'm the most current one at the moment. And then we can, I'm just backing up so we get to the page. And we can, the fact, well, we can try the full range of the L band and see how that changes with those coordinates you put in. You'll get a center frequency of 1500. If that is peaking, then that object there could be a satellite. I didn't notice too much difference. It might, well, you centered on that frequency. Let's try that. It's kind of like endless experiments you can do on this. Let's put that, what was it? It was 6 and it was 20. Yes,
Let's
plus 20.
go a little bit lower than that since we kind of missed it. Let's go, I don't know what that range is, 5.5 or 5.7. Maybe move it. Try.
Oh, here,
Try
5.7.
Yeah, 5.7.
Okay.
Declination 20.
Okay. And okay, we've got that. It's still within view, so I'll just put our initials in again so you can find it. I'll put number 2 there. And I'm going to change something because I've, you know, we're centered on those H1s. And if that is a satellite, it might be more obvious if we change to low and do the entire. And now you're centered on 1550. Just from doing a few of these, 1550 picks up sometimes the satellite signals. And as you're going through the data, you might see a quite larger peak, or the charts may show quite a large peak. So let's do that. I think we selected, oh, low resolution's only 1024. That might shed some light on it. And we're going to do a map again. So we'll do the 6 and 6 beam width is the minimum they say. We'll do the same 1/4 and 1/4 so it doesn't take too long. And we'll keep the integration time the same, 2.9 minutes. That's good. And here's the observation. And let's submit it and see what we get this time. Submitted successfully. And
there were options of 1/3 or 1/2 beam width. Can you start with that just to use less time and then do a more detailed?
You can do
survey
1/3.
afterwards?
The reason I picked 1/4 was there was a note there that said should be 1/4. Just like there's a note that says you should use 6 beam widths, you can go a lower number of beam widths, less. And I think that what that might do is increase your, well, your field of focus will become more narrow, I believe, because I've seen some of those where instead of a 6 by 6 degrees, I've seen people get down to 2 by 2 degrees, and it's a much more close up. And those are, and that's why going through the log, and there's a search capability in Skynet where you can search by a scientist's name. So sometimes what I do is Frank Eco, he's one of the scientists at Green Bank, I do Dr. Reichart, because they're more interested in maybe some serious research applications, and I like to see what they're doing and see if they've got anything interesting there that is worth a look. Or you can just do objects, deep space objects, planets, see what comes up. The quality of your observations are going to vary greatly on that, depending on whether you're getting student observations or somebody more experienced. I would recommend you look at my Raster Scan PowerPoint, because one of the things I was hoping to do is get some planetary observations. And besides Jupiter, you're really at the limit with Jupiter, with Skynet, and the others are kind of iffy. But there are observations by professionals out there, and I've seen everything but the planets show up. Just a lot of interference and noise of satellites, and by selecting the 1550, it became obvious. You'll see some examples in my Raster Scan PowerPoint that yes, that's I tracked it down to satellite emissions, and you can see how I did that. Or at least that's what my opinion was of what I was seeing. It kind of matched up well. I had some radio galaxies in the ecliptic that basically where you might have a sun, moon, and the planets move through. So let's, it's ready. Let's see if it's active. Let's see. There is oh, by the way, I had a printout of the analytical section page. There is, if you didn't jot down the Google search option I gave you, you can go to the analytical section website, and there is an entry there that says accessing the Skynet 20-meter radio observation archive. Press that link and you'll get to all the archive data. So that'll make it easy for everybody. And let me see if I put anything else in there that's, yeah, I think that was the key things. Let's see if this is done.
Going back to my question on Fitz file viewers, anybody have any recommendations?
Oh, well, I use for optical, I use that's on my other laptop. I use Astro Image J. I'm sorry I didn't answer that, but that was optical.
Well, it should work on this, right?
If these are Fitz files, I'm not sure what format they're in.
Yeah, Fitz is a standard file format, so it will read it. Yeah, if it's Fitz, any Fitz reader will read that type of file.
Because
Rich, this Jack, you could use QFitz View is one of them, and another one is the NASA one, which is FV Fitz Editor. But there's those are two Fitz file viewers that seem to work real well.
And Alex, when you were looking at that data, the spectral data, I don't know if you noticed, but there was a file name there and it ended in TXT. So it looked like it was in text format and not Fitz. So if it's not fit, I don't believe it's in Fitz, and
the label had Fitz on it.
Did it?
On the screens, yeah.
Oh, okay,
So
I didn't notice that. So maybe some of them do have Fitz. So that's good then. You have some options there. Let's check this again. Let me just refresh the page. Still active. So let's give that a couple more minutes. Let's see if there's anything else here. Oh. Somebody asked about the telescope sites. So you'll see this up here. You can go here. If it's letting me go here, it's, oh, maybe I have to pick it. Green Bank Observatory. Let's see what they say for Green Bank if there's a live view here. Well, it looks like it's just giving me, well, it's got some posted notes. That's good, warning us about offline time. Hardware updates, weather, the map, telescope status. So no live photos, but Skynet Live, let's see what that is, because I do remember seeing photos once on this site. Now these are all the optical scopes, obviously, but let's see if we can find Skynet in here too. Here's Green Bank. Well, it's not showing us anything different except that we've got everything. Oh, there it is. It's showing the status. Somebody at this optical scope is actually taking an exposure, an optical exposure. The help is you can attempt to get help from Skynet. I never got any help back. I don't think it's a very active help desk. Your best bet might be to throw out the questions on the SARA listserv and see if anybody can give some observing advice. Otherwise, just, you know, do some research yourself. And I think that's a good way to pick up some of these skills as well. And then if you're really stumped, then the SARA listserv, or I usually save a lot of my questions when we're at actually at Green Bank. So after I do my PowerPoint demo, and that's that open forum, informal, I might ask questions to the some of the members of the audience who might know these things. So I pick up some tips that way. So there's a lot to explore on the site. So let's go back to radio observing, and yep, it's completed now. So let's see what we get now with that different filter. So we're going here. And this happens sometimes where you think you got some observations and you get an error message, not enough data to make an image. At least they told you why in this case. That's an improvement. In some past observations, there wouldn't be a message. You just get a blank screen. So you might attempt again or try to do something a little bit differently. I don't know why it doesn't say there was enough data. You do have some of these files. No, it's not even, this is strange. I've never seen this before. Let's go back and resubmit and see if we can make that observation work again. Maybe we'll adjust the filters a bit. So let's add a new radio observation. Another thing I might say is an opinion again. If you don't have enough contrasting data, it might not give you an image. It might give you an image error. So we shifted the coordinates a bit, and I'm wondering if that radio object, we thought it might be more in the center, but maybe it moved off center.
Everywhere through there is a hot area.
Yeah, okay, so let's try then resubmitting with a different set of filters. So let's try the 5.7 again, plus 20. APST3. Save. Oh, the other thing we can do is, let's try this, another experiment. Notice how it defaults to RA declination. This is for the slewing. You can, oh, this is on the grid. I'm sorry. That's an option when you actually get into the display pages. Okay, so let's save this. Let's go high resolution again. We can change one of the frequencies. So it's, this is the hydrogen. So what I'm going to do here is 14, 21, 875. And we saw 1550. I'm choosing that because that was the center frequency on the low resolution scan, and you do pick up some interference there. I'm hoping it shows up in this raster. We have high resolution. Oh, now we have some more channels. Let's go back to 2048. Let's save. Let's do the map again. We can do 6 and 6, so we get the same coordinates. Did you want to try a third? Obviously you can. It's not going to be as, you want to see the effect if it gives us that.
Let's go all the way to a half, because it should be much faster. It should be a cheaper process to do
I've
that.
never done 1/2 before, so it'll be an experience for me too. And you can see here it's 43 seconds. Anything else we want to change? Okay.
If you haven't submitted, let's go 8 by 8. Let's
All right.
Put in 8 by 8 and see how much it costs.
It'll be a larger field of view, and it's not much change.
Let's go for it.
About a minute, so that's not bad at all. So you can see by playing with these gaps between sweeps and gaps along sweeps, you really reduce the raster scan charge. Save and continue. There it is. And submit. Let's take a look at this help while we're waiting for a moment. Actually, it doesn't tell us much. Contact us. Let's see who it says to so general inquiry. That's got my address there, but you could put your own in and select the topic and send the message there. I don't know what response you'll get. I think I've tried this a couple of times in the past and I don't recall getting a response, but maybe it depends, as the volunteers may have time or not.
Question?
Sure.
You were talking about a Frank, was it Gecko or something? Or
Frank Gigo.
How would I spell the last name?
I believe his, you would see, if you did a search of, it's F-G-H-I-G-O. F-G-H-I-G-O. It's in my raster scan because I did have a snapshot of a search under Frank, and he had some interesting objects there. And I dedicated one slide to that. And
I'm glad I asked for clarification. I wasn't guessing that spelling. You also said that on your analytics page over there on the SARA website that you had an entry for, what was it, like an index of the, or a link so that we could find different researchers or?
No, that was a, well, the 20, there is an instruction page and you have to explore it. But as you're going through the numerous pages of instructions, there is a search box that allows you to do that. And I'm going to refer you because I've got a snapshot of it. It might be easier this way. You can attempt to look at the various instructions that NRAO has out there, and hopefully you come to the search screen. But the other way to do that is on the analytical page, you'll see something called the Raster Scan Observation Program, and there's two links under it. One says access the update here. That's just the SARA section update, what's been going on the past few months. The other one says access the presentation here. That'll allow you to download the 50-slide raster scan PowerPoint that I'll be presenting in at the annual conference in the summer. And in there, I have a couple slides that show the search box. Hopefully you can, through that snapshot, maybe find it's not hard to find. I just would have to spend a little time there, but go through the 20-meter manual and main instruction pages, and somewhere in there you'll see the search box.
Okay, that gives me a clue. I find your presentation. I'll look at that as well. So much to learn. Thank you.
It is. It's I have been doing this for a few years now, as I have the time, and every time I try to start something new, I realize how much I don't know by learning new things. So let's check this. Let's go back. It's active. That's good. We'll give it a. Now let's see if I can maybe. I know what I'm going to do. Maybe real quick is I'm going to go to this other observation just to see if I'm going to go in here. The one that didn't work. Let's go into 20-meter information. Okay. Here it is. So did you see that? I went into 20-meter information. You get this header. You can go to the log, but then you can search projects right here. And if you press that, there you go. You can search by date, by source, and by user. So that's where you would put Frank Gigo in there. And if I have his name memorized, but it is also written in my PowerPoint presentation. So in case I'm off by a letter, you can find that here. And it's quite a large database, so you might want to start with just the, from January 2022 up to present, put in whatever source you want, the user, if you want a user, you can do, and then any type of report, track, on, off, daisy, the mode you can search by, the ID. So there's a lot that you can do in here, but that's where you find the search box. And then you'll get quite a large listing. So that is a useful feature I found. I like that. And then here's the Skynet University. That I think is the course. Let's see what that brings up. Some of these buttons I haven't presented. I haven't visited. Skynet University. That doesn't look like the Skynet University page. I would recommend that you just Google search Skynet University, and then you'll find the courses, free courses that Dr. Reichart has, and that you can go in to them. I did 2 of his courses, Radio Astronomy 1 and 2. They're very informative. I would recommend anyone to do them. It's just a broad view of astronomy in general, and it's at an undergraduate level. So that was very good, very interactive. You've got to pass the tests there. It's all pre-recorded, so you'll get the test, and you need a score of 70%, and some of his questions are challenging, so they're not that easy. You'll be making sure that you're trying to answer them properly. There are some challenges there. Okay, so let's.
Question, please.
Yes.
Listen, you talk about skewing. Now, are you electrically skewing the observation, or is it a mechanical feature? I'm not familiar with this telescope.
I believe it's the telescope moving back and forth on the sky, because it's making an image of the sky.
All right. Well, you could do that electrically in some cases, but I didn't know.
Oh,
thank you very much. Appreciate it.
That is my opinion. If it can be done, you mean by changing the angle of the receiver, maybe over the dish?
No, there are several ways of doing it, and
okay.
I just wanted to know if you know. I can look it up. I just have never paid any attention to this telescope before. As a matter of fact, I'm a brand new member of SARA, so I really don't know who the players are, and your relationship to NRAO is you're part of are you part of
no, I'm a SARA member.
Okay. Fantastic. Thank you very much.
Okay, yeah, come to think of it, it's got to be the telescopes skewing back and forth on the sky. I don't think the receiver moves, and in fact, I don't think that makes sense for this type of telescope. So let me retract that comment. But let's see what we get now. We changed the inputs a bit. Okay, now here that's why I wanted to do the 1550, because you can see there is a lot of interference over here that corresponds to satellite transmission, my opinion. You can look up these peaks of frequency, and a lot of times you'll find that there's a website that talks about a name of a particular satellite and that its operating frequency might be at 1552. Just experiment, Google satellite 1552 and see if you have something. And then you can see the other frequency was hydrogen. I think that when we did the first observation, it wasn't varying much because of the hydrogen, but when we switched the frequency to the 1500 or so, it showed that there was interference there. And I think that big red spot might have been it picking up these other frequencies. I'm not quite sure how that works. I know our center frequencies are on hydrogen. I'm assuming it's picking up some other frequencies as well. Maybe somebody with more knowledge can speak to that, but it definitely is here when we set it to 1550. Let's see what the map looks like. There we go. We've got those bright spots again. This is a little different though. This is at 22 and, because we've expanded it. Let me move this out of 22 and 84. All right, so I think it's not the same one that we had before at 20 and a half. And notice the power has changed. So whatever this is, I think this is causing your I think that's causing trying to move. I think that's what's causing this. I'm going to assume is maybe some hydrogen. It looks like. You can of course these scales I believe change because when you're calibrating you always have a different baseline, so you have to subtract that when you're trying to come up with actual flux values.
Hey Steve,
yes,
isn't the 1550, isn't that the frequency? So that is not hydrogen, right? That's your interference.
No, that's not. So I think, oh, here it is. All right, I wasn't looking at this. So this is centered on, that's interesting. I would have, if I didn't look at these frequencies, I would have thought this was the hydrogen because it looks like something you might pick up. And this would have been the satellite, nice and concentrated. But obviously it's the other, maybe way around.
Also, can you click that Fitz file
sure,
right above and just, no, down. It's right
so
above the
to
image.
be definitive, you would have to maybe go in and look at these files in a little more detail to see what is what here. But now you have this new clue where you have all of this and see where it's showing up in the file and if it's affecting any of these raster scans. It's kind of hard to do the interpretation in just a few moments, but those were.
No, can you click the title right above the image?
Okay, let me.
Where it says Fitz file. So scroll down to where those blue images are.
Scroll down to where
the images you were just looking at, down lower.
Okay. Oh,
there.
I see
like
that.
the title.
That's where it
Yeah,
was.
the title.
Okay. Yes,
Yeah.
great.
So
great.
is that a real? Does that give you the ability to download the Fitz file?
Let's see. Wants to download multiple files, so it looks like you can. It's allowing that.
You don't have to do it. I just want to make sure that.
Yeah, so it looks like you can do that. Well, that's good. It looks like it was just blocked on mine because I didn't give it permission, but there you go.
Now, those two bottom plots, when I do raster scans in my noisy high school environment, that could be RFI showing up, and it looks like a big blob at that particular time in the raster. Is there how is Green Bank? Is it quiet or is it noisy?
No,
and
very
then,
quiet.
All right, so we say that's not RFI, and
Well,
general opinions, how could you prove that? Would you simply run it again and see if it shows up?
Well, it's not RFI from the ground. It's going to be RFI in the sky, and that's going to be satellite. My quick opinion here is you're picking up all these frequencies here, which I think correspond to satellites, and that may be in these images. Now, Rich had a good point. Why is it showing at 1550 here and it's scattered all over here like a hydrogen cloud? And here it's 1425 and it's more concentrated. I would have to do, more interpretation on this, but you would have to look at the files and check and see if you can match up something.
Hey, Steve.
Yeah.
We got 10 more minutes. I was wondering if you could do a quick pulsar. I think 0329 plus 54 is up. And that'd be a great one to finish off with.
Okay. And I've noticed the pulsar data, because I was looking at a lot of pulsar data in the archives, and it's not really good data. And I think because maybe they didn't put great input parameters in there. But let's take a look. I was exploring it, but that was so casual at the time.
I've had good success with a longer time. People want to do seconds on those things, but you need like at least 30 seconds or something like that.
Yeah, the instructions recommend 60 seconds for a bright pulsar.
Okay, and that's 0329 plus 54 is the brightest you're going to get, I think, at this. 0329 plus 54.
Oh, that's the coordinates. Oh, okay.
No, that's the name.
That's the actual designation, how it goes. And O is going to be 0, not the letter O.
Yeah.
Okay.
Oh no, that's right. I see it on the chart. So
let's see if it brings it up. No matches were found, so it needs another name.
Put B in front of it.
B, okay. And let's see if I need a space or not, but that might help. No, let's give it a space. And let's space this plus.
Is it?
Wow.
Am I missing that, guys? Is it 0329 or 032? It's on the screen. Maybe you can click it.
Okay. Where on the screen is it?
Slightly higher, right there. Down. Down, down, down. See the B there?
Oh, okay. B0329 plus. Okay, so everything is together.
Well, that's it. Try
That's
clicking
what we
that
had
guy.
before. Okay. So why didn't take it? Let's see if it takes it now. All right, let's see if we can hit it. Wow.
that a 0, B0329?
Yeah, that is a 0 because the O looks like this.
Okay.
Do you have a common name for it?
No.
Uh,
Just do B0329 and see if it picks it up.
yeah, I noticed the search option on this is not the best. But let's see. You got an asteroid. You don't want that.
Huh.
Wow. Maybe if somebody can do a Google search for me and see if it has a more proper name, and then I can put it in.
That's the name it has.
Oh, okay.
I'm afraid that's the name it has. There's no other common name.
All right. So that's unusual that it's got it listed here, but it's not. I wonder if I'm experimenting here. Pulsar. You have to do that.
It looks like it might be BO instead of B0.
It has to be B0 because that's a coordinate essentially.
That's the right ascension.
Um,
Well, I'll say you could plug in that. I guess you could plug in the coordinates and then use pulsar mode.
What about using PSR in front of the number? In front of the...
that's a good thing. That may work. I remember sometimes you have to put. That's it.
There it is.
Thank you. I had somebody ask me once for a variable star, not the radio bright, but I got the V numeric after it, and person couldn't get it to pull up, and I said, well, you have to put the constellation name in front of it so that it knows what constellation is. So that's why I was thinking sometimes they want some kind of qualifier in front, and in this case it worked. So that's great. And I'm not sure if the instructions are actually say these things, so they're not always that clear. So we are okay. So I'm going to submit, and then we want low resolution for pulsar mode, because that's the only place you'll get the pulsar mode checkbox. And then I think the path on, oh, wait, I don't think it matters what you put in once it's in pulsar mode, even though it's defaulting to map because that's what we used last time.
I would say track. You don't want to track it.
Yeah, yeah. Well, that's right. That makes sense. You want to track it because you don't want to map the whole sky. I think the pulsar box overrides everything. If you're saying that's very bright, I would use a lower integration time. Maybe that. And duration, should we give it 60 seconds?
Sure.
Save and continue. You know, I didn't give it a name. So when anybody who looks this up later on the public log, you're going to have to look for this. I won't have my initials after it. So just remember that. And then we'll submit it. And we'll see what kind of quality report we get. Now, when you do see the report, you're going to see all these boxes, and you might want to ask, if you haven't seen pulsar data before, what do all those boxes mean? Well, all you have to do is go to the SARA analytical section page and go to the 20-meter pulsar observation program, access the presentation here, and it has a whole bunch of slides on what each of those boxes mean. And that will help explain it. And that was from an internet source. I took it, very helpful internet source. I believe I have the credit given to the person. I can't remember his name offhand, but his manual is on the internet and it's very helpful. Okay, let me give that some time. How are we doing on time? Are we going to cut off at 4? How does that work?
Well, normally we'd cut off exactly at that time, but but let's just get this Pulsar done, and then take about 10 minutes to do that, and then we'll cut off.
So that's good
while I
that
got
it's
everybody
active.
on, while we're waiting on this thing, does everybody like to have these RTOP sessions? And what would be the next telescope you'd be interested in seeing? Type of telescope.
Yes, I enjoyed this.
I enjoyed this also, but anything is new to me, so whatever.
That's to all of us. I mean, even the experienced people have not seen a lot of this stuff. So what other telescope, and does anybody have a telescope they'd like to demonstrate?
Any telescope is okay with me.
Okay.
The weather is too unpredictable down here in Florida right now. You know, you might see a thunderstorm, so good out to pass, maybe in the fall.
Okay. Well, what I've got lined up, but I don't have next month lined up, but I have the Radio Jove guys are going to do a demonstration with the new Radio Jove, and the Deep Space Exploration Society is going to do the moon bounce and show how moon bounce sounds with the when they do that. There's a lot of super-SID people and meteor detection people that I'm gonna try to get on to. So I'm looking for recommendations, especially if you have a telescope you'd like to demonstrate. And I think every time someone demonstrates something, it helps. And we're trying to get this one as opposed to Drake's Lounge. This is more astronomy observation based, and how to use your telescopes, how do you analyze the data, and what kind of science you get out of the astronomy side. So that's why we're concentrating on this.
I'm setting up a meteor observation telescope myself here.
Oh, is that a volunteer to demonstrate that there?
Yeah, I can do that probably in a couple of months.
All right.
Or-
All right.
so.
Ah. We have that happen sometimes. You get this error message. It took the observation and then it gives you this. The URL does not exist. So you would have to resubmit it.
Oh, try it again.
Refresh.
Okay.
I'm not resubmitting it. See if it shows up again.
Oh, I think it, yeah.
Oh,
It
all right.
happens once in a while for whatever reason. I don't think we did anything wrong with that. We can try resubmitting and see what happens.
It sounds like their internet connection went down.
Here it is. This time I'm going to put, I'll change it a bit to number 2 there. Yeah, we didn't do anything wrong. That just happens. Before I figured out how to reduce the time on the raster scans, I used to be displeased when that happened because it would eat up so much time, and I didn't have any data then. Oh, I wonder if we had to switch to all. That might have made the difference. Let's try that. We're keeping all that data, save and continue. That may have made the difference. So let's see if we can get it to work this time.
Rich, you were talking about future presentations. Live demonstrations are exciting, as we see. How do you want to handle taped reservations or presentations?
Well, I think it's going to be a mixture of both. I think that what I'd like to have is somebody showing how their telescope works, and maybe that could be live, and then the actual observation could be taped because of all the issues we're having, like we're seeing here. And maybe we just sort of have that ahead of time that, hey, here's an observation that actually did work, and here's how it looks for real. And here's the data it comes up with. But maybe you know, we can have a sort of a viewpoint of here's how you operate the controls is live, but maybe you know, just to guarantee we have a real observation, we can have that taped. That make sense?
Very good. I just want to consider. That seems like a nice. We'll get more presentations that way.
Yeah, I think so. And by the way, on Little Thompson Observatory, I would not mind having you guys give a presentation on the optical telescope you got there and maybe showing how that works. That'll help a lot.
I think it's a great idea too. I'll go find someone to do it.
Okay, thanks. See, I guess this volunteer stuff actually works.
Yeah, but you gotta get results, so we'll see.
So you'll have a choice with this recording, whether to edit out the things that didn't work or keep them in. There is some value when things didn't work, because then people see, there was an error here, and that's how it was corrected. And that is a valuable experience in itself sometimes. Like us putting in the PSR for Pulsar. If we didn't have that little bit of searching there, and people didn't see that the PSR made a big difference, it might have been oblivious to them that it was necessary to get that, instead of just putting in the B in the coordinates. So I guess we'll see how this session records and what we think is valuable to keep or to edit. Okay, so this is completed now. So this time I had a larger range instead of one narrow frequency filter. Let's see if it works. Yes, it did. So that made a difference.
Got it.
So yeah, when I saw that narrow filter, I figured, oh, that's why we don't have enough data. It needed the full range. My opinion, but it worked, so that's good. So here you see everything, and actually this is looks like we got a nice bright pulsar spot there. So by selecting that integration time by what is the period on this anyway? Do you know offhand?
0.714 seconds, 740 milliseconds.
Okay. Well, I picked the lowest integration time that we could. That was that I saw in the instructions beforehand. So if you want to know what each of these boxes mean, you can look at those slides that I had in the 20-meter pulsar observation program. There's so we got our results.
So very, that's excellent results, by the way. Others need to analyze it, yeah.
and this whole data sheet is a whole presentation by itself, right, what everything means. Right. So I'm glad we got that in there and it worked then.
Okay, any last comments, and we're going to sign off.
Thanks, Stephen.
You're welcome. And again, contact me if you want to sign up for the SARA account for this.
Done.
Thanks so much.
Yeah, you did a good job. It's running the telescope and doing all this stuff and talking about it at the same time is very tricky. It's like singing and playing the guitar, I think, together.
Okay, yeah, that's good. So yeah, I don't have the time to do this on the demo with the PowerPoint, because you can see how much time it just the live session took. But when we're at Green Bank, that's we do the PowerPoint and this until all the questions are answered. So. And it's not part of the normal speaker series. It's I believe it's on the first day. I think it's the we usually have a Saturday the first day. That's when a lot of the beginners, first time attendees come to SARA. And right after dinner, we have the 20-meter demo and discussion, and it kind of goes We've exhausted all questions. If you've not been to the live SARA meetings at Green Bank, I think it's almost a 24-hour event there. There's something all day long going on. This will get done, and then people will start going over to the 60-foot telescope. Is that right? I think so. I think it's is that right? 60 foot? I forgot the feet on that. Or 40-foot telescope. That sounds correct.
It's Skip Curley's 40-foot telescope.
40-foot telescope. Yeah. That's not a remote scope, so you have to be there, but it is open to everybody on campus there that stays, and you can spend as much time on it, and some people through the night stay there. And then there's the actual Drake Lounge, which goes to midnight. And then you have some people who bring their optical scopes out at night. So if you can deprive yourself of sleep, it's literally a 24-hour day in Green Bank.
Okay.
Well, just real quick, since you're recording, Rich, I want to make sure that we acknowledge that it's not my telescope.
Oh, I know.
Yeah, sorry, I know. Yeah, I do love it, but
all right.
It's
Thanks, Skip.
It's Green Bank, yeah. Okay.
All right. On behalf of the SARA group, Stephen, you did an outstanding job. Thank you very much. And I think we'll sign off now. Everybody, start looking at the YouTube page. Has all the past conferences on there. And we're going to start adding some history files. Charles Osborne has got a hold of a bunch of tapes or videos from our past meetings with some dignitaries there. And he's putting up, we got a new history section in the journal that Charles is putting in. So we'll see all that. By the way, great journal this time. And by the way, we need directors, and a vice president and president nominations. So if you're interested in doing that, volunteer or nominate somebody. Check if you nominate somebody, check that they want to do it first. But we're interested in getting some people for this election. Okay. Thank you very much, and we're going to sign off.